This episode is brought to you by Ross Video. From video switchers, graphics, and routing, whether SDI, IP, or even in the cloud, Ross makes live production easy. Trusted everywhere from the biggest sports stadiums to city council meetings, newsrooms, and more. Are you ready to upgrade your workflow? Keycode Media offers the best Ross Video pricing and a free consultation, so you get the right products the first time. Trust the experts at Keycode Media and book today at keycodemedia.com. Have you ever watched a production and thought, wow, that lighting is perfect, but then the host stares into the void like they forgot how to read? Yeah, that's because they didn't use ICANN. See, ICANN makes top-tier studio lighting, prompters, and gear that keep productions looking and running smooth. So whether you need buttery soft LED lights or rock-solid teleprompters so you don't forget your lines, or just pro-level gear that won't let you down, ICANN has you covered. So if you want your production to look like $1 million without spending $1 million, check out ICANN. Because great lighting and a good prompter can make anyone look like a pro.
Three, two, red, one.
Welcome, everyone, to Broadcast to Post, and today we're diving into one of the most important areas of transformation happening in our industry right now, the modern broadcast newsroom. See, newsrooms are under even more pressure than ever. Stations are producing more hours of live programming, delivering content across broadcast, streaming, and social platforms, and doing it all with leaner production teams. And at the same time, the technology powering those newsrooms is evolving rapidly. We're seeing major shifts towards IP-based infrastructure, increased use of production automation, and new studio designs built around LED displays and more flexible production environments. So the big question that many engineers and operations teams are asking is, how do we increase production capability without increasing complexity? So to help break that down, we're going to start with a look at some of the key considerations shaping modern newsroom design. I'm going to hand things over to Steve Dupay from Keycode Media, who'll walk us through a few of the biggest technology trends that we're seeing across broadcast facilities today. Steve will also be joined by Jim Bean, VP of Engineering and Operation at Fox's WTTG and WDCA stations, to talk about how these ideas are playing out in a real-world newsroom environment. Then I'll see you later for Q&A. So Steve, take it away.
As newsrooms continue to evolve, the pressure to produce more content across more platforms is only increasing. Stations today are delivering not only to traditional broadcast, but also to streaming platforms, social media, and mobile devices, often all at the same time. And they're doing it with smaller teams and tighter production schedules and budgets. That raises an important question many broadcast engineers and newsroom operations leaders are asking right now. How do we increase production capability without increasing complexity? When stations begin planning newsroom upgrades today, a few key considerations consistently come up. Let's look at some of the biggest trends shaping how modern newsrooms are being designed. Number one, the shift toward IP-based infrastructure. One of the biggest architectural changes happening in newsrooms today is the transition from traditional SDI infrastructure to IP-based media transport. Standards like SMPTE ST2110 and NMOS, along with technologies like NDI, Dante, and others, allow video, audio, ancillary data, and metadata to move across standard IT networks rather than dedicated baseband cabling. We actually have a number of past Broadcast to Post episodes that dive deeper into this topic, and we'll include a few of those in the description. At a high level, IP-based infrastructure enables far more flexible production environments. Signals can be routed anywhere across the network. Production resources can be shared between studios or control rooms, and systems can scale more easily as facilities expand, at least on paper. That's the pitch. But the transition to IP also introduces a new set of engineering challenges. Network design becomes critically important. Engineers need to consider bandwidth allocation, multicast traffic management, redundancy strategies, and especially precision timing systems like BTP, which synchronize IP-based media environments. One of the things we consistently see when helping customers to make this transition is that IP systems behave very differently than traditional baseband infrastructure. In the SDI world, the signals are highly deterministic. You run a cable, and the signal either works or it doesn't. IP systems are a completely different animal. They operate inside a shared network ecosystem where timing, traffic prioritization, and device interoperability all matter. Even something as simple as an IP to SDI gateway can vary significantly between vendors in terms of buffering behavior, latency, and standards compliance. Industry guidance from SMPTE and organizations like the Video Services Forum also highlights the importance of monitoring and orchestration tools in IP facilities. Engineers increasingly rely on network analytics platforms to track timing domains, multicast flows, and device behavior across the facility. For many engineering teams, the shift to IP isn't just a technological change, it is also an operational shift that requires stronger calibration between broadcast engineers and IT network specialists. Number 2, automated production control is becoming the backbone of production. A major shift in newsroom operations today is the growing role of automated production control, often referred to as APC. Automation platforms coordinate many of the elements required to produce a live show. That includes switching cameras, triggering graphics, rolling video clips, advancing prompters, and controlling camera robotics. Platforms like Ross Overdrive, Viz Mozart, Sony ELC, and Grass Valley Ignite allow newsrooms to run complex productions with fewer operators while maintaining consistent production quality. These systems also integrate directly with NRCSs, short for Newsroom Computer Systems, by using MOS protocols, which allow editorial rundowns to drive production events in the control room. Automation also enables repeatable workflows. Camera movements, graphic timing, and segment transitions can all be executed consistently from a rundown. In many facilities today, automation has effectively become the central nervous system of the control room. But successful automation deployment depends heavily on design and integration quality. When problems occur during a live production, the root cause often isn't the automation system itself. It's usually a configuration issue somewhere else in the chain. For example, tally might not trigger properly because of telemetry configurations between robotics and the automation system. Or graphics timing issues can arise from mismatched MOS configurations between newsroom systems and graphics engines. That's why systems architecture, device drivers, and integration testing are critical parts of newsroom automation projects. Automation works best when the entire production ecosystem, including switchers, graphics, servers, robotics, and newsroom systems, is designed to operate together from the start. Number 3, LED walls are transforming studio design. Another major trend reshaping newsrooms is the growing use of LED walls in display-driven set design. Traditionally, new sets relied on physical scenery and fixed backdrops. But LED display technology is allowing studios to become much more flexible and dynamic production environments. With large LED walls integrated into the set, broadcasters can quickly change the visual environment without physically rebuilding the studio. The same stage might support a morning show, a financial segment, weather alerts, election coverage, or even an entirely different program later in the day simply by changing the graphics and content on the displays. What's interesting is that the set itself is becoming part of the production technology stack, introducing new engineering considerations. Engineers now need to account for factors like pixel pitch and camera distance, camera sensor interaction and moire, color calibration and HDR workflows, LED processor latency and refresh rates, and synchronization between LED processors and the graphic systems driving them. These aren't trivial design and operational decisions, and working with an experienced system integrator can make a big difference. We're also seeing tighter integration between LED walls, graphics engines, and automation systems so that display content can change dynamically as part of the production rundown. As a result, engineers, graphics teams, and set designers are increasingly collaborating much earlier in the design process to make sure the studio works seamlessly on air. Number 4, metadata-driven workflow and multi-platform publishing. In today's platform content world, modern newsrooms are no longer producing content for a single output channel. Instead, content must be distributed across linear broadcast, streaming platforms, website, mobile apps, and social media. To support that kind of workflow, production systems increasingly rely on metadata-driven operations. Metadata allows newsroom systems, media asset management platforms, graphics engines, and automation systems to exchange structured information about stories, clips, and show segments. Industry analysts and standards organizations like SMPTE frequently describe the future newsroom as a data driven production environment where metadata enables automation across the content lifecycle. For example, metadata can help automate tasks like clip creation and highlight generation, graphics population and templating, captioning and transcription generation, and digital publishing workflows. Many vendors are also integrating AI assisted tools that analyze media content, generate metadata, assist with story preparation, or accelerate clipping and publishing. These capabilities are still evolving, but they're becoming an increasingly important part of the newsroom technology strategies. Number 5, cloud and hybrid production workflows. Finally, one of the fastest growing trends in broadcast operations is the move toward cloud and hybrid production environments. Rather than keeping all infrastructure inside a single facility, broadcasters are increasingly distributing workflows across on-prem systems and cloud-based platforms. Hybrid architectures allow organizations to scale compute resources for tasks including graphics, rendering, media processing, archive storage, remote editing, and disaster recovery. Cloud-based production tools also enable new collaboration models, allowing journalists, editors, and producers to work remotely when needed. Major broadcast vendors, including Sony, Grass Valley, VizRT, and Ross, are all investing heavily in cloud-capable production platforms that support both on-prem and cloud-based workflows. That said, industry experts consistently emphasize that most broadcast operations will remain hybrid environments for the foreseeable future. Latency-sensitive processes like switching and live studio production often stay on premises, while compute-heavy tasks such as media processing, archive management, and distribution move into the cloud. Designing these hybrid workflows carefully is essential to avoid introducing unnecessary complexity, operational risk, and additional cost. When you step back and look at these trends together, a common theme emerges. Newsrooms are becoming more flexible, more automated, and more visually dynamic. But that flexibility also increases the importance of thoughtful system design, infrastructure, automation systems, graphic engines, and display technologies all need to work together reliably. And honestly, we just scratched the surface. Technologies like bonded cellular encoders from companies like LiveView are reducing the need for traditional satellite trucks and making live field contributions far more flexible. At the same time, advancements in camera robotics from companies like MRMC, real-time graphic systems from companies like Brainstorm, and of course the big buzzword right now, AI-assisted production tools, are continuing to transform how news stories are produced and presented. If your organization is evaluating a newsroom upgrade, exploring IP infrastructure, or looking to modernize your studio design, the team at Keycode Media works with broadcasters across the industry to design, integrate, and support these systems. Hi, Jim. Welcome back to Broadcast to Post. You've been leading engineering and operations at Fox's WTTG and WDCA stations for nearly 2 decades, and your team is producing an enormous amount of live programming every week. We're also joined by Nick Kumar, Vice President of Broadcast Engineering at Keycode Media. Nick has worked with many broadcasters on major infrastructure transitions and actually partnered with Jim's team during their move to a new facility and transition to SMPTE ST2110. Great to have both of you here.
Hi, Steve. Thank you. Hello, Nick.
Hi, Jim. Hi, Steve. Glad to be back.
Thanks. Jim, before we dive into the technology, can you give us a quick overview of the type of programming your newsroom is producing today?
Well, it's ever expanding. Currently, we're on from 4 a.m. to midnight with some sort of live programming. Much of it traditional newscast or traditional morning newscast, but we've expanded into things that are a little bit more topical, maybe a little bit more controversial opinion. And then on the streaming side, we're doing sports, entertainment, and just a lot of live. You might say what's happening now on the streaming side. So we've It's we've really expanded in the last in my time here.
Wow. Yeah, you'd mentioned on a previous call that you're producing about 100 hours of programming every week, much of it live. How has the scale of production changed over the past 10 to 15 years, and what pressure does that put on you, on engineering, and your production teams today? And maybe give us a sense of the types of shows you were producing years ago versus what you're supporting now.
I mean, years ago when I started, most of the newscasts were your traditional newscast, one or two anchors, big desk. You've seen them, and we still do those newscasts. But the audience has is really driven us to produce other programming, and it, much of it adjacent to a traditional newscast, but in a different way. You might be familiar with the national show TMZ. We do a show very similar to that in our newsroom, where we focus on the District, Maryland, and Virginia, the DMV zone. It's a little bit different pace, a little bit faster pace, higher story count, and we maybe cover stories in a little bit different way sometimes. In terms of the pressures and the scale of production in the last, 10 or 15 years, I'll tell you one thing: our maintenance window has really shrunk. I mean, it's almost down to nothing. We did we had to update some network switches just this afternoon, and we have maybe a 2-hour window to work in when we're not on the air, and even in that window, we are live streaming to our digital platforms, and we struggle to get maintenance done anymore.
Yeah, it's that 4 a.m. to midnight time frame doesn't leave you a whole lot of time, and those got to be awful overnighters as well.
Yeah, yeah. I mean, we wrap up at midnight and we're back on live at 4 a.m.
Wow.
So, even that window, you'd say, well, you got a 4-hour window there, but it's hard to do maintenance in the middle of the night.
Yep.
There's just the support's not there.
Yeah.
Um, yeah.
One thing that stood out from our conversation was how flexible your studio environment is. You essentially have one studio with two sections, and you're able to quickly transition between very different types of programming throughout the day. For example, in the morning, the anchor desk can be moved out of the way for dance or exercise segments, while other shows might use couches or a completely different set
Mhm.
configuration. And then you have an LED wall and three monitors that can operate independently or combine into a larger display backdrop. Can you walk us through how the studio was designed and how your team is able to transform this space so quickly between shows?
So, and I'll talk new building and old building because 5 years ago we were in our old building, and that building was 60 years old. But we had two studios in the old building, and we would sometimes drag cameras from one to the other, and we would have people running from one to the other, quickly. Floor directors moving around. We decided, look, we're going to do it all in one big studio, but we still have separate areas. So it's almost a studio with 3 or 4 corners. Um, we've got, a mix of traditional set pieces. And we've still got the couches for people to sit on, the chairs. We still have risers on wheels. We still push the desks around on wheels. But then the backgrounds and the background monitors and the foreground monitors are all under graphic automation control.
Mm.
So this studio, we can change the look of any of these corners. At one point during the week, it would look like a courtroom because we produce a court show. Late at night, we do a show called The Final Five. It looks like a rathskeller. All this is handled and controlled by our graphics automation, which are under the production control room automation control. So the same system that controls the play out and the robotic cameras and the switcher also drives the graphics. And uh, with a template-based graphic system, our producers can they call up the same graphics that they use every day for most of their shows in the background. But then when they want a different graphic, they can call it up from something that's built, or they can even drop in a JPEG into a template and allow it to build a new graphic.
Hmm.
So we have monitors that are on rails that hang on rails, and there are four of them pushed together, and you can operate them as one, or you can split them into two monitors, or you can split them into four monitors. And it all depends on the look that you want. And it really allows us to get many, many different looks with a very short turnaround time between programs.
That's amazing. Nick, from the systems integration side, we're seeing more studios designed this way. What does that take technically to build a studio that has that kind of flexibility?
Yeah, so from the integration side, flexibility really comes down to designing the studio as a technology platform rather than a fixed set. So at WTTG Fox 5, we built the infrastructure around an IP-based video routing system, centralized and flexible control, and modular set elements so the space could essentially adapt to different shows throughout the day. The LED wall, monitors, and graphic systems are all tied into the same production backbone, so operators can quickly change layouts, sources, and backgrounds without physically rebuilding the set. So when you combine that with the newsroom automation and programmable control systems, the studio team can then shift from a traditional anchor set show to something more lifestyle or interview driven in just a few minutes. Another big piece was the whole routing and control layer. We designed the system so two different production control rooms could essentially take ownership of the same studio with essentially the push of a single button. And behind the scenes, what that does is it triggers automation presets, switcher profiles, routing changes, and monitor layouts. So the entire signal flow uh, basically reconfigures automatically depending on which control room is driving the show. And that's really where the industry is headed. You know, studios that are multi-purpose production environments where technology and automation give producers the flexibility to tell different kinds of stories in the same physical space.
Wow. So Jim, this transition that Nick helped you to go through occurred about 5 years ago. That had to have been a major facility transition when you moved into the building and had all this new SMPTE SD2110 infrastructure. At the time, that was still relatively early in the industry adoption curve, and Nick was actually part of that integration, as he's just mentioned here, and helped to design and deploy the systems. Um, from a broadcaster's perspective, what was the transition like, and what were some of the biggest lessons you and your team learned during that deployment?
From my standpoint, it wasn't as hard as you might think, and I want to say that's in part due to Nick and his team. Nick will give you a different answer on that. I guarantee you that under the hood, look, we were struggling. It was a greenfield facility. We took almost nothing from the old building into the new building, so in that respect, we had the luxury. Most companies doing a 2110 transition won't have this luxury, but we had the luxury of building a new facility, testing it, and then moving into it. And that was a luxury. Um, you know, we were we were making these decisions really now 6 years ago, right? Because we were having to
Yeah.
decide ahead of time what the equipment was going to be, and we were an early adopter. We were still a few years after the 2110 standard was released, so there was equipment out there. I'd say the difference, 5, 6 years ago from today is we had the choice between, maybe one and a half different brands of switchers, maybe two different brands of cameras, one, maybe one and a half types of graphic systems. Of the equipment that a station, that our size would normally procure from vendors, our choices were pretty limited, but we did have a workable choice in each category, and so that was good for us. So we weren't really, all the way out there on the bleeding edge. If we were designing it right now, we might make different choices. we would certainly have many more choices than we did, 5 or 6 years ago, which is a great thing. If you're transitioning now, there's so much more out there that wasn't there 5 or 6 years ago.
Right. Well, and I think you were very fortunate. Nick is one of the top design and integration engineers in 2110 and an NMOS in the industry. And I think you were pretty fortunate to have him helping you with both your design and your integration.
Mhm.
Nick, without without showering too much on you, what were some of the technical challenges and considerations when helping Fox move to a full SC2110 environment at that time?
Appreciate the kind words, Steve. Thank you. So, from the integrator side, one of the big realities at the time was that the SD2110 set of standards were still very new, as Jim mentioned. The standards had only been ratified really a couple of years ago before we actually started doing the design itself. So while the industry was excited, right, about the IP and ecosystem, about the IP adoption, the ecosystem was still very much maturing at the time. So one of the first things we did was spend a lot of time understanding Jim's operational pain points at the old facility, and then look at how a greenfield design could essentially solve those issues. And given the scale of Fox's operation and at the time, moving to a native 2110 IP architecture just made sense. But it also meant that we had to be very cognizant and deliberate about vendor interoperability and vendor selections at the time. And at that stage, you couldn't just take a vendor's word that a device was 2110 compliant. We relied heavily at the time on the JTNM interoperability test results and worked very closely with manufacturers to understand how their equipment actually implemented the standards and what level of NMOS support existed with those manufacturers. In a few cases, we found gaps, which meant we had to engineer some pretty innovative solutions. But another big shift was in the design methodology itself. With SDI-based systems, a line drawing, for example, can tell it can tell you most of what you need to know about the signal flow, right? With IP systems, the physical network, the logical network architecture, and the multicast design all become critical parts of the system design. So we were thinking about things like topology, multicast management, routing protocols, and control orchestration very early in the design process. So it really forced us to design the facility from the endpoints perspective, outside in, understanding what each device could do, then building the network architecture, the architecture and the broadcast control system around that. So looking back, it was definitely early days for 2110 deployments, but projects like Fox, WTTG5, helped prove that a full IP broadcast facility could be built and operate successfully at scale. And in many ways, the industry, it sort of learned together through projects like this. Broadcasters, integrators, and vendors all working through together to really make this project successful, as well as build a standards-based IP facility.
Yeah. And Jim, that kind of goes to the whole point of you were coming out of a traditional SDI plant. You were dealing with point-to-point connections and fixed signal paths that were easy to interrupt and test and all that kind of stuff. How has moving to the IP-based environment changed the way your team routes and manages signals or reconfigures your production resources across the facility? Has it made it more complicated? Has it solved some problems? Has it given you some new flexibility?
It's certainly a different way of looking at it. In some ways, it's much more complex, but in other ways, once you immerse yourself in it, you get to understand it. It's actually easier. Um, you know, Changing signal flow in a 2110 facility, you don't have to touch the cable. You're sitting at your desk, on your PC, um, whatever the control software you're using to manage your network and your facility, and you're making the changes and then saving them. And then if you don't like it, you can just load the previous config. Or in our case, if it's Wednesday afternoon and we're switching from production control room 1 to production control 2, um, we do that one week out of a month. We switch to the alternate control room. It's 2 buttons. It's one for video, one for audio, and all of those routes are changed. think about it. The teleprompter monitor that's on the front of the camera, that needs to be fed from the control room. Well, which control room are you in today? And you have all those little decisions have to be made. All that can be done from, with a push of a button. The engineers who are used to troubleshooting and working with SDI-based systems, if the station all of a sudden goes to black, the engineers get up from their bench and they run into master control and they run into the room with the equipment racks, and they start troubleshooting it. Not the case with 2110. We see black on the air and there's a problem. The engineers actually sit down at their desks and they start logging into the different computer systems that are monitoring the network, and they see the whole signal flow out on on a multi-viewer from end to end, and or on any of a number of different tools that we use for network analysis that can see the multicast flow from one end to the other, and it's a different way of working. Um, Surprisingly, or maybe not surprisingly, I think our staff picked it up very well.
That's fantastic. And kudos to Nick for such an excellent design.
Mhm.
That kind of begs the question, Nick. You obviously delivered a powerful solution to Jim, and have helped him be more successful. What were the biggest hurdles that you faced in trying to design a solution that would have that kind of added capability and flexibility of operation? And what were some of the biggest successes you had in deploying that IP infrastructure for him?
Yeah, so one of the biggest engineering shifts, if you would, when moving from baseband to IP, is that you're no longer just connecting devices. You're building and operating a networked system. And in the early days of 2110, that meant we had to spend a lot of time validating how different devices actually behaved in a live environment. And, like I've emphasized before, the standards were relatively new. And while vendors would say their equipment was 2110 compliant, the reality was that implementation details, they varied from vendor to vendor. So some devices, for example, they supported parts of NMOS, like ISO4 discovery, but didn't fully implement ISO5 connection management yet. So integration sometimes required some pretty innovative solutions, which I'm sure Jim can attest to. And because of that, stress testing at the time became really important. We would test systems not just for signal flow, but for operational behavior under real production conditions. For example, routing changes, traffic bursts, failure scenarios, PTP failures, and so on and so forth. For example, in one particular case, we discovered an IP receiver in a production switcher that was sensitive to bursty multicast traffic. And it ended up causing artifacts across adjacent inputs. And diagnosing something like that requires being able to analyze packet behavior, understanding the device's IP receiver implementation, and then working closely with the vendor to develop a fix. But first, being able to properly communicate the problem. And these kinds of challenges were pretty common in the early days of IP, but through careful testing, collaboration with vendors, and really understanding both broadcast workflows and network behavior, we were able to deliver a stable system and get WTTG successfully on air.
That's fantastic. Let's shift gears now for just a minute and talk about another big trend that we've been discussing today. That is, and that is automation in the control room. Jim, your facility uses systems like Ross Overdrive and Grass Valley Ignite. How much of the production process today is automated, and how has that changed the role of the technical director in the control room? You mentioned earlier that sometimes the switcher is executing the show automatically while the TD is focused more on managing robotic cameras. How does that workflow work in practice?
There are I think three or four big players out there in production automation. I think they're all good. But yeah, you're right. The TD is not necessarily so focused on the switcher anymore. Um, all of the effects and everything and all are built in. And so the punching that the TD would do is now they're spending more of their time, watching the newscast, touching up the cameras, framing shots, maybe looking ahead, routing live shots that are coming in, maybe just checking the quality of a live shot, advancing graphics. There's a lot of other work to be done in there.
That's interesting. It feels kind of like it's giving you the opportunity to have a more immersive, more enhanced production value, rather than just doing the rote stuff that tied down engineering stuff. You're able to help the creatives be maybe a little bit more creative.
Yeah, I think so. I think that these production automated automation systems, and they're pretty mature now. Um, they allow us to produce a very repeatable, fast-paced, interesting show that maybe in some cases has more production value than you could do, if you were having to manually punch the buttons. You've only got so many fingers and so many buttons you can press at once, but the computer makes it all happen, and keeps it on time.
That's cool. Nick, in order to integrate all that cool automation stuff together, it takes a lot of configuration, a lot of scripting, a lot of stuff to make that work well together and not have glitches on air. What were some of the challenges you ran into in with the automation systems and orchestrating all these different devices to work together seamlessly?
From an architecture standpoint, one of the biggest challenges with automation is that the system is no longer just controlling one device. It's orchestrating an entire ecosystem of equipment in real time. And newsroom automation systems, for example, like Overdrive or Ignite or others, they're simultaneously talking to, for example, your production switcher, your graphics engines, clip servers, robotic cameras, audio mixers, routing systems, and often lighting or video wall processors. So, for that to work reliably, every device has to expose stable control interfaces and respond predictably when the automation system sends commands. So, a big part of the integration effort is making sure that all those control layers are aligned, whether that's through MOS workflows with the newsroom control system, device control protocols, NMOS connections and IP environments, or even traditional APIs and serial control. Another challenge is making sure that the system still allows operators to intervene when needed. Automation is great for consistency and predictable outcomes and efficiency, but live television may be unpredictable at times. So the architecture has to support both automated workflows and manual control at the same time. And when it's designed properly, automation doesn't remove operators per se. It essentially allows them to focus on higher value tasks like camera framing, storytelling, and managing live production, rather than just executing button presses.
Yeah, interesting. Um, from an operations standpoint, what are some of the biggest challenges that you're facing today in running a modern newsroom? And I think you mentioned earlier that more people involved in the production today may not come from traditional broadcast backgrounds. How is that changing the way, say, your engineering teams support production?
We need to lay the groundwork for our staff that uh, maybe doesn't come from a production background. Maybe maybe they've come from a journalist background, and we've tasked them with doing a hour-long streaming newscast or from our streaming control room area. Um, and they need a little bit more help, a little bit more instruction on how to make it work. Um, and so our engineers have spent an awful lot of time in the newsroom, working with people that don't have the traditional production background. 20 years ago in this business, if you were going to be operating a switcher, in a top 10 market, you probably had 10 years experience to start with. Now you might be a producer, and you still may have the experience as a producer, but you have not spent a whole lot of your career punching a switcher. And if you find yourself in doing a streaming newscast where you need to be operating a switcher, um, it's a challenge for you. And we've spent a lot of time now with our engineering staff helping these folks get up to speed, and then helping them when they bump into problems that maybe you know, a TD with more experience maybe wouldn't have.
Makes sense. Um, we have a lot of vendors, I'm sure, watching this show today. So, Jim, from your perspective, running a high volume newsroom, what's on your technology wish list? What is it that might be missing today that would be great to have? And, what problems could vendors really engage in solving to help your facility operate better right now?
Lighter, less expensive, easier to control, right?
Yep. More bang
Yeah,
for the buck.
more bang for the buck. It is remarkable the state of the industry right now. And 20, 30 years ago, we did things a certain way, and you know, bought the same equipment as the other top 10 markets, and operated it the same way. And now, uh, our the way that the equipment that we purchase maybe is lighter and easier and more automated, and the people that are operating it have different backgrounds. And so we'll be out there at NAB looking for all of that.
Good to know. Nick, are you hearing similar kinds of requests and status from other broadcasters that you're dealing with on designs and integration?
Oh yeah, absolutely. I mean, we're definitely hearing some of the same themes from other customers, other broadcasters across the industry. And one of the biggest requests that we hear is around simplifying interoperability. And over the last several years, the industry has made a huge progress, right, with standards like 2110 and NMOS. But in real life deployments, there's still a lot of effort to make multi-vendor systems behave like a single cohesive environment. Broadcasters really want systems that integrate more seamlessly out of the box, where discovery, connection management, monitoring, and control, they all essentially work together without requiring as much custom engineering. Another area we hear a lot about is operational visibility. In an IP-based facility, there's a tremendous amount of data flowing through the network, and operators want better tools. Engineers, they want better tools to quickly understand the system health, troubleshoot issues, and visualize what's happening across the entire production infrastructure. So, if there's one common theme in the feedback we hear, it's that broadcasters are looking for solutions that make these complex systems easier to operate, of course, easier to monitor, and easier to integrate as facilities continue to scale and evolve.
Yep, I absolutely agree with that one. One final topic before we wrap up. With technologies like IP infrastructure, automation, robotics, et cetera, becoming more common, the skill set for engineering is evolving pretty rapidly. What training resources or learning paths do you think are most valuable and applicable right now for engineers who want to stay relevant in the industry? And both Jim and Nick, why don't you provide us an answer on those?
Uh, Networking, of course. Certainly know different protocols, multicasting or multicast protocol. Just being nimble. Um, we've had we've had success in with our engineering staff in hiring people from a number of different backgrounds. Um, some networking, some traditional broadcast engineering, some audio engineering, um, some former military. We've had just a great success with hiring people lately, and so yeah, I don't know if you're seeing the same thing, Nick.
Yeah, and I think this is a it's a great question, and the role of um, a broadcast engineer, as Jim mentioned, is definitely evolving. It has been evolving over the last 6 to 7 years. In the past, a lot of the focus was for a broadcast engineer. The focus was baseband video systems and signal flows. But today, with technologies like IP, 2110, automation, and even cloud-based workflows, engineers really benefit from having a strong foundation in areas like networking, um, understanding IP infrastructures, and software-defined systems. So learning the fundamentals of things like network architectures, multicast, PTP timing, and maybe even basic Linux or scripting tools, for example, they can go a long way. And these skills help engineers understand not just how the equipment works, but how the entire system behaves. So at the same time, I'd also encourage people not to lose sight of the broadcast fundamentals, right? So understanding production workflows, signal integrity, and how live television actually operates. The engineers who are most affected today are the ones who can bridge both worlds. And there are some great resources out there, whether it's organizations like SMPTE or VSF, industry training from groups like Avixa, or even online networking courses. But probably the most important thing, as Jim mentioned, is just staying curious and continuing to learn, because the technology in our industry continues to evolve pretty quickly. And the engineers who will thrive in the future of broadcast are the ones who understand both media and workflows and modern IT infrastructures and bring those two worlds together.
I love that. Be curious, engaged, and always learning. That's fantastic. Well, Jim and Nick, this has been a fantastic insight into what it really takes to operate a modern newsroom. Thanks for joining us and sharing your experience.
Thank you, Steve.
Thank you, Steve.
We're now going to transition into our live audience Q&A, so stay tuned and let's get some questions in here.
Thanks for watching Broadcast to Post. Don't forget to follow KeyCode Media on social and contact us about your projects at keycodemedia.com.